Welcome to the First Impressions Podcast, the official podcast of the Forum of Incident Response and Security Teams. Every month, Chris John Riley and myself, Martin McKay, share informal conversations with security professionals from around the globe. The opinions expressed in this podcast are those of the speakers alone, and any sarcasm you hear is purely intentional. For more information on FIRST or this podcast, please check out first.org.
Hello and welcome to the podcast. This is Chris John Riley. I'm here with my co-host Martin McKay. We're lucky enough to be talking today to Lesley Carhart, Hacks for Pancakes Online, who did an amazing keynote presentation on day one of the FIRST conference, talking about how do we get here, talking about industrial control systems. Lesley, welcome to the podcast.
Oh, thanks for having me.
More than happy to have you, and we'd be happy to talk to you all day if we could. But can you give the listeners who didn't have a chance to see the presentation just a quick TLDR what you covered in the keynote?
So I do industrial incident response. So incident response in places like power plants, water, manufacturing, transportation. And I talked about how we're in the situation with cybersecurity we are. So I did a little primer on how those systems work and what can go wrong in them and the history of attacks against them and what we're seeing now and what we're expecting to see in the future in terms of cyber attacks against those cyber physical systems that do real physical things in the real world.
At the beginning of your keynote, you gave an amazing analogy. We've already talked to Spaff about analogies, but we'll go with the analogies regarding a revolving door, which ever since that point, I've been unable to walk through a revolving door. As you mentioned, the amount of people who are injured by them. It was a very simple and easy to understand example, which it was amazing. Most people talk about ICS and they make it overly complicated, something that's very hard for people to grasp. But the whole concept of a revolving door just seemed like it was beautifully done.
I've got to give people a really simple example of an industrial process because doing this well doesn't come down to any whiz-bang techie stuff. It comes down to understanding processes, and those could be mechanical, electrical, or chemical, and the devices that provide control for those. So I introduced a concept of a control loop, and a control loop is a simple diagram that you create to understand how industrial processes work. So a door is real easy. Every control loop has three parts. It has a sensor, an actuator, and a controller. The controller is the thing, whether it's gears and pulleys or a computer that makes decisions about when the door turns. The actuator makes the motor go. It makes the door turn. And the sensor knows whether you're in the revolving door or not. It's sensing motion or pressure. And those three things work together to make that door go. And as you get more and more complex whiz-bang industrial processes, they're made up of control loops still, and the same types of things like them not starting when they should or not stopping when they should can go wrong with any complicated industrial process. So next time you walk into a spinning door, start thinking about sensor, controller, actuator.
Yeah, I think that one of the most embarrassing moments in my professional life was walking into a man trap and having both doors lock and say, you can only have one person going through there at a time. But no. The fact that you were bringing up how historically this isn't a new concept, that there are mechanical versions of this from thousands of years ago, that there are the real stuff that we know of now as ICS only started 70 or 80 years ago, maybe a little bit more for even some of the simpler stuff, but a lot of things have not changed in that time. In fact, some of the equipment's probably the original equipment from 50 or 60 years ago.
Yeah, the life cycles are really long, and the bottom line is these processes just have to work. We want them to work as efficiently as possible and do things on a big scale of production and for a lot of people and just-in-time logistics, but in the end, these processes just have to work. We can't screw them up adding more whiz-bang cybersecurity things to them or doing incident response. Like, they just have to go. When you hit the big red button on the stop button on the wall of your factory, it means to stop things right away. These are fairly simple systems in a lot of ways, although we've added a lot of layers of complexity to make our complex SCADA systems with lots and lots of parts of their production across the globe in the last few decades.
I mean, you bring up a good point there about it being old systems, about they just have to work. And you mentioned in your keynote about how we lack understanding more broadly about ICS and SCADA systems. We're hitting that same problem that mainframe users are hitting of people are retiring, that skill set is disappearing, and we don't have the tools to do incident response, which is what you're covering in great detail on these systems, because the tooling is not designed for Windows NT 351 and OS2 Warp.
Yeah, it's a big space. Industrial is as wide a space as the rest of cybersecurity. We've got tons of verticals. We've got tons of ages of technologies and tons of vendors in different spaces. And all those have different requirements in terms of connectivity and operating systems and tools for security. So there's a lot of diversity in this, the creativity that we have to come up with to do forensics and security logging and analysis on sometimes 30-year-old systems and sometimes very customized, non-standard operating systems, custom firmware, things like that. It's an interesting and exciting space to work in.
You use the example of the revolving door, but you also talked about how many people get hurt in that, which kind of leads us to the other part of what you were talking about, which is in some of these systems, they're delivering medicines, they're trying to deal with mixtures of chemicals, and if they're not working precisely correct, it's deadly.
These have real consequences, and I made the whole audience repeat after me one word in the talk that if they learned nothing else and they were half asleep and they were drinking their coffee, I wanted them to go away with the word consequences. Everything we do in cybersecurity and industrial comes down to real life consequences, which is things like people dying or getting hurt or the environment being contaminated or a facility setting on fire. Real life physical things result in what happens to these industrial systems. And everything we prioritize and do and make decisions about and establish risk for in these environments have to come back to those potential consequences that we don't want bad people to cause, and we don't want to cause as security practitioners either.
When you're doing incident response on ICS SCADA systems, I mean, you mentioned that it's very, very different. I mean, certainly we talked a little bit about the tooling and the age of the systems, but also what the customer wants to get out of incident response. Do you just want it running again? Do you want to understand how they got in so they don't get in again? Do you just want to understand what's going on? How do you find that people coming into this industry, maybe from a traditional incident response, handle that change of focus?
Not well. It's a big challenge because we are socialized as cybersecurity people to just want to get the malware out of things. Like our priority is, there is a virus, let's get rid of the virus. Let's re-image the computer. Let's install a new operating system. Let's patch. You don't have any of those tools available to you in a lot of industrial environment. There is no XDR. There is no modern forensics tools. And every decision you make has to, again, avoid causing consequences like a loss of warranty or downtime or potential latency or incompatibility with low-level devices by upgrading an operating system. You've got to think about all that stuff. And it's not always your decision. You have to work with the operators and engineers who know those systems much, much better than you do. So it's very frustrating for new cybersecurity people coming into that space, into the OT space sometimes, because you have to make concessions. You have to be willing to adapt. You have to think of other solutions than the really obvious ones we're used to in cybersecurity to make these systems safe.
Chris mentioned OS2 Warp. I mean, and I have to wonder how many of our listeners are going to have to go out and Google that. But it leads directly to one of the other points you made, and Chris alluded at earlier, is we have people retiring from our industry. We have people who have had years of experience with Novell 312 or NT 351, well, Windows 351. And those people are retiring. We can't exactly teach new students those skills unless we actually make a point of teaching them those skills.
Yeah, it's a real big problem, and I'm going to use my term here that I'm trying to coin against all the legacy people in this space who don't like me coining new terms. But we talk about a convergence of IT and OT technologies. We see a convergence there because people are using more and more IT technologies like Cisco and Microsoft in OT environments because it's cheap. But I see a divergence in skill sets, especially in differ and security operations centers, because the new people who are coming into cybersecurity now learn how to use tools. They learn how to rely on XDR in their first SOC job and in their degree and stuff like that. They learn how to rely on modern operating system forensics tools. And you do not get that. You do not get that in your OT environments. So you have to be able to think creatively. That's the integral thing, and that's a hard thing to teach.
One of the things you ended your presentation with was talking a little bit about that brain drain, teaching new people, getting those kind of tools. what is the next step for us as an industry to try and make this better? SCADA, ICS, it's not going away. It's going to be here for many, many years. It will still be running OS2 Warp or worse. I can't think of anything worse right now, but I'm sure there is worse things. And we need to do better. We need to train better. We need to share knowledge better. We need to have resources that people can use and not endanger people's lives and the consequences that you mentioned.
I think the biggest thing that we've got to do is we've got to fight some misconceptions that are in our collective subconscious as security practitioners about OT. We make assumptions like, they just don't want to patch, or they just don't care about cybersecurity in OT. That's not true at all. They have different priorities, things like consequences, things about supporting legacy systems that are incredibly important. And they're important for life safety reasons. We've got to get around those misconceptions we have about OT. We've got to start having conversations and dialogue with the engineers and the operators and training our people accordingly, especially our junior people, letting them shadow, letting them understand this stuff. We have had bad relationships between operational environments and IT cybersecurity for years and years and years, and that's a heck of a thing to beat.
I think conversations are hard for most IT people, especially people in security. People come in with their views and then say, this is the way it should be done. This is the way security needs to be done. And I think listening may be a skill that we need to develop there.
We can't know everything. We can't know everything about these OT environments. We're not chemical engineers, most of us. We're not electrical engineers, most of us. Those people who are specialists in those OT systems are going to know more about those systems and their safety and their operation and their consequences than we ever will. So we have to work with them, and we have to be humble. And that's very, very hard as techie, hackery people who want to know how everything works in the world. And it's unfortunate we can't know everything. None of us can know every niche. None of us can know every detail about these processes. We have to start listening and trusting and having conversations with operational people too.
I would have hated to have been the first OT responder to say, I'll just run Metasploit and see what happens. That is not something I want to be the person doing in a train environment or in a hospital. I've
gotten called in to do IR in environments where people who don't know anything about OT have done that in an IR. And one of the companies actually went out of business. I've seen that. I've seen environments severely damaged by people doing IR poorly in operational environments. It's crazy.
You touched on one point there, which is around patching of systems. And traditionally, when you start to think about security of systems, people immediately think vulnerability research. I'll find bugs in these systems and then tell them so they can patch them and they can be more secure. And having done research on ERP systems, SAP, for example, the patching cycle is 6+ months. You don't say, here's your 90 days patch, and then I'm going to release the exploit. That's 60 days, 90 days. It's 6 months to patch something. And I'm guessing in an ICS environment, you're looking at 6 years, not 6 months. So are we doing more damage than good if we start to look at these kind of systems?
I see a lot of cybersecurity people who want to get into the industrial space just like buying a PLC and trying to do bug bounty finding in it. That's great. Find the vulnerabilities in industrial systems. That's great. Do it in a safe way. Don't do it in any live process environment. But if you want to buy some stuff off eBay, sure, research it. Find out how it's vulnerable, report it. That's great. CVEs are important in the industrial space too. But honestly, most of these systems are somewhat vulnerable by design because they have to be really, really simple. They have to not have overhead from encryption or overhead from security features. They have to work safely and quickly and efficiently, sometimes in very low bandwidth environments and on low resource systems. So I describe it this way. I say that there's a crispy candy outside to most of these environments, we hope, and a squishy inside to that candy.
But this goes back to your favorite word, consequences.
Yep. Consequences are, again, if you're listening to this at home right now in your car, whatever, I'd like you to say the word consequences with me. Consequences. If you want to do this, everything has to come back to mapping out a worst day ever and what's going to actually practically cause that. Because if the entire environment's infected with Conficker and it's not going to cause a consequence, well, then that environment's probably going to be infected with Conficker for a while.
If it's not going to affect the running of a key service, then disrupting it just to get rid of it, that sounds like a bad idea.
Sometimes shutting down these environments can cost millions of dollars an hour.
Or result in unforeseen consequences like sewage being pumped into a lake.
Oh yeah. Good times.
For people who are listening who might want to get into the ICS space, find out more information and be maybe part of the solution in the future, how can they find out more information and learn more?
So my CEO at Dragos, Rob Lee, has a nice blog on his personal blog on resources for getting into ICS cybersecurity, which include training, and they include courses, and they include videos to watch. So that's a really good resource to go to. There's, of course, paid training in industrial cybersecurity, but the price is very certainly. And other than that, if you work in an environment where there is a process environment of some sort, just shadow. Go ask questions. Just be humble and try to learn a little bit more about how that environment works and what your operators and engineers in the OT environment do every day. Learn their terminology. Learn what they care about. Be a good listener, and that's going to teach you a lot right there.
Yeah, but just don't plug in and run a Nmap scan.
No scanny. No scanny.
Consequences.
No scanny.
Thank you very much for taking the time to chat with us. It was a wonderful keynote. If people have the opportunity to watch it, they should. And if they have the opportunity to watch you keynote or present anywhere, they definitely should. Thank you so much for joining us.
It was a pleasure.
Thank you for listening to the First Impressions podcast, and thanks to this week's guest. You can find Chris John Riley on Twitter at Chris John Riley, all one word. You can find me, Martin McKay, on Twitter at MCKEAY. And you can find the FIRST organization at first.org, FIRSTDOT.org. You can also find more information about FIRST and the First Impressions podcast at first.org. Thanks again for listening.